Dear students, today we discuss about the problems on capacitor. Here I have taken 5 samples of problems. Let's start from the first. Here assume the area of each plate. This is 1 plate, 2 plate, 3 plate, 4 plate. Area of each plate is same and separation between adjacent plates is same. That assumption I am taking. Okay, I will go with the first. Assume here this is connected to positive of the battery and B is connected to negative of the battery. Alright. Now name the plates first. This plate is 1, this is second plate, this is third plate, it is fourth plate. Now take point A here. I'll take the point A here, right? This point A is connected to positive of the battery. Now point A is connected to second plate. So I'll just mention here second plate. Okay, this point A is connected to second plate. Now point B is connected to third plate. I'll take point B here. Okay, this is B here. So B is connected to third plate. Okay, again this B is connected to negative of the battery, that is there. Now plate 1 and 4, they are neither connected to A nor connected to B. So I'll just take one here, and this 4 here. I'll take this 4 here, right? Now I'll go on place the capacitors. Okay, between 1 and 2, these two plates, whatever capacitor is forming, I'll call it C1. Between 2 and 3 capacitor forming, I'll call it C2. And between 3 and 4 capacitor forming, I'll call C3. Now let me go for placing the capacitor. Between 1 and 2 plates, where is 1? Here is 1 and 2. Between 1 and 2, capacitor C1 is there. I'll take here capacitor C1. This is C1 here. Now between 2 and 3, C2 is there. Where is 2? Here is 2. Here is 3. Between 2 and 3, one more capacitor is there. What is that capacitor is? Between 2 and 3, it is C2 is there. Now between 3 and 4, C3 is there. Where is? Here is 3, here is 4. Between 3 and 4, C3 is there. I will take here C3. This is C3. Okay. Now between 1 and 4, just it has been short. That is one connection wire is given here. This is like that. Now from here onwards, it will be a very simple thing. Here the C1, C3 are in series, and this combination is in parallel with C2. Right? Now you can find that here anyhow capacitor area is same and separation is same, so that's the reason. Definitely C1 is equals to C2 is equals to C3 is equals to say, and definitely it is what? Epsilon naught A divided by T. Okay. Now go for finding it. As C1 and C2 are in series, what is the effective capacitance between that? C dash is equals to, in series, let me write C1, it is C3 divided by C1 plus C3. What is C1? C into C divided by C plus C, it is 2C, it is C square by 2C, it will be what? Finally it will be C by 2. Now here this C dash is in parallel with C2, therefore total effective capacity between A and B, I call C double dash is equals to, in parallel combination, what is the formula? C dash plus this C2. What is C dash? C by 2 plus C2 is C. Then it will be what? 3 C by 2. We know what is C. It will be 3 epsilon naught A by D. This is 2 is there, 2 here. This is what the effective capacitance between A and B. Right? Start the second one. Right? Let me start the second one now. So here I'll go with second one. Okay. In the same way, I'll name these plates. Plate 1, plate 2, plate 3, plate 4. Right? Here again assume A is being connected to positive of the battery and B is connected to negative of the battery, right? Now again the same way, place point A here. I'll place the point A here. A is connected to 2 here. Now I'll take point B here. B is connected to plate 3 here, right? Now 1 and 4, they are neither connected to A nor connected to B. Let me take 1 here, and then I'll take here 4, right? Now I'll place the capacitor. Okay, between 1 and 2 the capacitor C1, between 2 and 3 I'll call the capacitor C2, between 3 and 4 it is C3. Okay, now between 1 and 2, C1 is there. Where is 1? Here is 1, here 2. Okay, this has been again continuous to positive of the battery. This is being connected to here negative of the battery. That is, the imaginary battery is connected there. Now between 1 and 2, as I told, one capacitor is there. That is C1 is there. Now between 2 and 3, C2 is there. Where is 2? Here is 2. Here is 3. Between 2 and 3, one capacitor is there. Between 2 and 3 it is C2. Now between 3 and 4 C3 is there. Where is 3? Here is 3. Here is 4. Between 3 and 4 one more capacitor is there. What is that? C3 is there. Now what is 1 and 4? 1 here, there the plate 4 is not at all connected to 1. But 1 has been connected to where? 3. Where is 3? So okay, 1 is directly connected to 3. 1 is directly connected to 3. So ultimately I will take like that. So for timing I will take it like that. Okay. Now very clearly this C3 one end has been connected to negative sides. C3 one end has been connected to negative, but other end is unconnected. So that's the reason it will not at all store any charge. So we neglect it. Right? Now this is quite easier one. Now in this line only this C1 is there. In this line C2 is there. So it will be as if only two capacitors are connected in parallel. Right? Now this is very simple. So therefore effective capacity between A and B is equals to C1 plus C2. Right? We know it is all C1 and C2 are same dimensions. Therefore I will take it is 2C here. This is equals to 2 times, what is C? Epsilon naught A by B. This is effective capacitance between A and B. This is how we can do it. Now in the same way, let's go for the next one. Now the third one, So here, same way. Here A is there. A is connected to positive of the battery, B is connected to negative of the battery. Just name the plates. 1 plate, 2 plate, 3 plate, 4 plate. Here between 1 and 2 capacitor I will call C1. Here one important thing we have to notice here. Plate 2 and plate 3 are connected to same polarity. Let us say assume negative of the battery. If suppose 2 is connected to negative, 3 is connected to negative, then 2 and 3 will not form capacitor. Okay, capacitor should have different polarity to store the charge. So here there is no capacitor here. So here 3 and 4, let me call the capacitor will be what? C2. Okay. Now in the same way, let's again this is point A and this is point B. Here point A is connected to 1 and as well as 4. Now so therefore point A is connected to 1 as well as 4. So point A is connected to how many plates? 4 plates, and point A is connected to first plate. And here B is connected to 2 as well as 3. Let me take here B is connected to 2 as well as 3. Now, so let me go on now, please. Okay, between 1 and 2, what is capacitor? C1. 1 is here and 2 here. 1 and 2, what is the capacitor here? 1 and 2. What is capacitor between 1 and 2? C1. Let us say it is C1. Now between 3 and 4, one more capacitor. Here is 4, here is 3. Again let me write it into anyhow it is going to positive of the battery, it is going to negative of the battery. This is junction. So here one more capacitor is there. So this is there. What is here this capacitor between 3 and 4? This is C2. Now again it's a parallel combination. It will be what? Here. So therefore C effective can call it is C effective capacitance between AB is equals to, again it is C1 plus C2, then it will go 2C, then it will go 2 times epsilon naught A by D, right? This is how we can do it. Okay. Now let's start the same type, another problem here. Alright, another problem I'll go with. Similarly, let's name the plates here 1 and 2, 3, 4, 5. Again, you assume A is connected to positive of the battery and B is connected to negative of the battery. Here, I will take this point A here. A is connected to how many plates? 2 and 3. I will write 2, 3 here. Now, I will go here B. Here is B. And B is connected to how many plates? Plate 1 and plate 5. So here plate 1, 5. Okay. Now, so here 3. Okay, sorry. 3 is also connected to what? I'll just write here itself. 3 is also connected to, it is B. This is there. Right. Now, okay, I will just name the capacitor here is C1, between 2 and 3 capacitor is C2, 3 and 4 capacitor is C3, and 4 and 5 it is C4. Right. Now, between 1 and 2 C1 is there. Where is 1? 1 is here and 2 is here. 1 and 2, what is capacitor is C1. I will call it is C1. Now, between 2 and 3 C2 is there. 2 is here. Okay. Now, here the A is connected to 2 as well as 4. Here the slide I have to take here 4 because A is connected to as well as 4. Okay, now next 3 and 4. Between 3 and 4 C3 is there. 4 is here, 3 is here. Let me take one more capacitor here. This is C3. Now between 4 and 5 C4 is there. 4 is here, 4 is here, and then 5 is here. I'll just take one more capacitor here, right? So this is what? C4. Now, okay, this is continuing. This is connected to negative, it is connected to positive. Here definitely all the three are connected between two junctions here. They are connected in parallel. So therefore, as they are connected in parallel, effective capacitance between A and B will be C1 plus, here what? Where is C2 also I should have taken here. Between 2 and 3. Between 2 and 3. C1 is between 1 and 2, okay. 1 and 2, C1 is there, I taken here. Between 2 and 3, C2 is there. Okay, C2 should have also been taken here. This is C2 here. So this is C2 here. Okay. Between 2 and 3, between 3 and 4, what is here? C3 is there. C3 also has been taken here. This is C3. Then between 4 and 5, here 4, here 5. What is between 4 and C4 is there. So here 4 capacitors are connecting in parallel. So I'll take C1 plus C2 plus C3 plus C4. Therefore, effective capacitance between AB is equals to 4 times C. Therefore, effective capacitance between A and B is equals to 4 times epsilon naught A by D. This is the effective capacity. In the same way, let me complete the last one. The same way, like call 1, 2, this is 3, 4, 5. Again call this capacitor is C1, this is C2, this is C3, this is C4. Now again the same way, A I will take here. So A has been connected to 5 plate and 3 plate. I will take 5 here and it is 3 here. I will take B here. B has been connected to only 2 plate here. Okay, now this plate 1 and plate 4 neither connected directly to A nor to B. I'll take here this 4, I'll take here 4, and then this is one more is 1, so I'll take the point 1 is here, right? Now I'll go and place the capacitor. Between 1 and 2 C1 is there. Where is 1? Here is 1, here is 2. Between 1 and 2 what is there? C1 is there. I'll call this is C1. Now between 2 and 3, C2 is there. Where is 2? Here is 2, here is 3. Between 2 and 3, what is that? Between 2 and 3, just I'll take here. Between 2 and 3, which capacitor? C2 is there. Now between 3 and 4, which capacitor? C3. Where is 3 and 4? Here is 4, here is 3. So I'll place here one capacitor. What is between 3 and 4? What is this capacitor is? This is C3, right? This is C3. Now in the same way, C4, 4 and 5. 4 and 5, between 4 and 5, C4 is there. Where is 4? Here is 4. Here is 4 and 5 is here. Between 4 and 5, one more capacitor is there. Just I'll take here that capacitor. What is this capacitor is called? It is C4. Okay, now between 4 and 1, just it's only short. I mean here just with one, it has been made short. So it has just connected with a simple wire. Okay. Now very clearly here this C4 and C3 are in parallel. Okay. And this combination is in series with C1 and this complete is in parallel with C2. Now okay. What is C4 and C3? Let this be first C4 and C3. C4 and C3 effective, let me call 4, 3. It will be C4 plus C3 is equals to 2C. Right? Now, this 2C is in series with C1. I'll take between this C4, 3, like between this and this series connection is there. Let me call C dash. It is C1 into this 2C divided by C1 plus 2C. This is equals to, as C1 is again a C. So 2C into C, 2C square, then 2C plus C, that is 3C. So it will be 2C square divided by 3C. Here CC gets cancels, here C dash is equals to, it will be through 2 by 3 into C. Now this is completely C dash. This C dash is in parallel with C2. Therefore, effective capacitance between AB is equals to C dash plus C2. What is C dash here? 2 by 3 C. Again C2 is again a C. Then it will be what? It will be what? So it will be 5 C divided by 3. I mean it will be 5 by 3 epsilon naught A by D. Right? This technique will help you to find effective capacitance between such a type of arrangement of plates, right? So now we discuss about the effect of dielectric on various factors of parallel plate capacitor. Here the first case I will take introduction of dielectric without disconnecting the charging battery. So here this is here capacitor and it is connected to a battery here. This is battery of capacity V volts, positive, negative. This is the capacitor, its capacity is C. Here when vacuum or air is there, its capacity, we know what is its capacity, epsilon naught A by D, where D is the separation between the plates, A is the area of the plate. Here the moment if we insert the dielectric between the plates, dielectric, what do you mean by dielectric? It's an insulator. The effect of dielectric is to reduce the electric field on behalf of its present. It will reduce the electric field. In turn, it will increase the capacity of capacitor. So, okay, let me start here. The moment when we insert here dielectric of dielectric constant K, then without, I am not disconnecting the battery. Battery is connected. So between the plates, slowly I will insert the dielectric without disconnecting the battery. Then what will happen? What will changes happens to electric field between the plates? What changes happens to potential difference between the plates? Then what is the changes in the energy stored in the capacitor after introducing the dielectric? And after introducing the dielectric, how extra charge that battery is putting in the capacitor, and we will see one by one what are the effect on electric field, effect on potential, effect on energy stored, effect on electric field, effect on charge, how many it will extra store after putting the dielectric. Let's see one by one. First let me take first one capacity. First let me take here capacity. What will happen to its capacity? Okay, effect on capacitor. Before initial capacity, let me take Ci. It will be what? Epsilon naught A by D. After substituting, after putting the dielectric, then with dielectric, let this be C dash is equals to, what will happen here after putting the dielectric? So it will be, we know it already, K times epsilon naught A by D. So here K into, what is epsilon naught A by D? It will be C here. So therefore capacity increases by K times. Now second one, let me go now. Second one, what will happen to its voltage? Let me go to the voltage, potential difference. I told you, let's see what will happen to potential difference. See, before introducing dielectric, its potential difference across the capacitor is, let's say, V. Okay, so after putting dielectric, let this be V dash here, it will be equals to V. There is no change in the potential difference, because whatever changes may happen in the capacitor, but the battery is here. He will maintain what he can. He will maintain the same potential difference, because what is its capacity? He will provide the same voltage to the capacitor. Whatever may happen inside the capacitor, but batteries keep connected. So ultimately, he will keep the same potential difference across the capacitor. So therefore, potential difference will remain same even after introducing. Now, what will happen to charge? So we know what is the formula. C is equals to Q by V. So internal, right? Q is equals to C into V. Here Q is the charge stored before we put the dielectric between the plates, and C is the capacity of the capacitor before we introduce the dielectric, and V is the potential difference between the capacitor applied by the battery. Now once we put the dielectric, what is the charge storage is, what is capacity becomes C dash. What is voltage? Voltage doesn't change. Potential difference across capacitor remains the same. So therefore Q dash is the charge stored is equals to, what is C dash? We know it, K into C and V. Therefore what is C into V? It's an initial charge storage. So therefore, charge storage will increase by K times, right? So definitely once you introduce the dielectric, the charge storing capacity will increase. Right, capacity will increase, charge storing capacity also, charge storing value also increases here, right? Okay, now what will happen to energy storing capacity? Okay, I'll just, what will be energy storing? So here, initial energy stored in the capacitor before we introduce is equals to half CV square. Here I could have taken even Q square by one more formula, Q square by 2C is also there. So there Q is also variable, C is also variable, so I don't want to make the things complex. So here any of V is constant, I'll go with this formula, half CV square, V is constant. Therefore final energy stored U dash is equals to half of is C dash, any of potential difference doesn't change. So U dash is equals to half, what is C dash? K into C into V. Sorry, this is what? V square. So U dash is equals to half, okay, CV square, I'll write it separate, and K I'll write it separate. Therefore energy stored will be K times, what is this? Initial energy stored. Therefore this is U. So energy stored will also increase. Right? So definitely the moment when we introduce dielectric, capacity will increase. So charge storage will increase. in turn even the energy storage is also increasing, right? Now next one is, okay, let me go now. The next one is, now let us see what will be effect of this dielectric on the electric field. Okay, now electric field formula we know it, E is equals to potential difference divided by D. Remember, as V doesn't change because he is there, whatever can happen, he is there, no, he will keep applying the same what he can. So therefore even diamond D, separation between plate, is also not changing. It's not comes under variable dimension. So therefore here V is not changing, D is not changing, therefore I could write here it is equals to E dash, that is electric field does not change. Even you go with another way also, it's not the only way. What is the electric field between the plates? Sigma by epsilon naught. This is the formula before introduction of the dielectric. When you introduce the dielectric, what will happen? When we introduce, actually sigma is what? Charge per charge density, charge by area, epsilon naught. This is before introduction of the dielectric. When we introduce dielectric, E dash is equals to, charge is increased by what times? K into Q. A, remember epsilon naught, when some medium is there, then medium property changes to K into epsilon naught. Here again K gets cancels, what you are getting? Q by A into epsilon naught, still it is equals to what? A. So even in this way also you can confirm. So even directly use this formula also you can confirm. Then definitely there is no change in the electric field value. There is no change in the electric field value, right? So therefore now electric field doesn't change, it remains the same. In the same way, now question comes, initial charge before introduction of the capacitor dielectric, initial charge is this. Sorry, initial charge is, where is initial charge? Actually let me call Q with the initial charge. After putting dielectric, what is the final charge? K into Q. Extra charge delivered by battery. What is additional charge given after putting the dielectric? Additional charge given by battery is equals to additional charge, final charge minus initial charge, it will be Q common, K minus 1. This is extra charge capacitor will have after putting. That's what it is advantage, right? So very clear, electric field is same, potential is same, right? Electric field is nothing is changing in, but potential is same, but here charge capacity will increase. Okay, under the same potential difference it will have higher charge, right? So that's what advantage. You will learn it later. Dielectric breakdown. See, dielectric breakdown of air is very less. If you put any insulating medium, any dielectric medium whose dielectric breakdown is more, then definitely you have more flexibility until that dielectric medium converts into conductor. You can put more charge, you can create more electric field, you can create more potential difference, because the insulating material has got more bearing capacity, because it can bear more without breaking it into conductor. So that's what advantage here, charge will increase. How much energy will increase? Final energy, what is initial energy will be this one. So increase in energy, I'll take one more here, increase in energy, delta U is equals to final energy stored minus initial energy is equals to, what is final energy? K into U, initial energy is U, therefore I'll write here, what I can write, increase in energy is equals to, here U common, K minus 1, what is U here? Half CV square, K minus 1. This is what increase in energy, right? Increase in energy also will be that, right? Let's now go for introduction of dielectric after disconnecting the battery. Now what we do, See, this is capacitor here. So with the help of battery, I'll first store the charges. Okay, now first I'll store the charges. After storing the charges, now I'll disconnect the battery. So this is capacitor. Now it has been disconnected from the battery. It has got. Now after disconnecting from the battery, now I'll introduce some dielectric medium. The dielectric medium has got value K. So here only air is there and this has been charged with the help of battery up to charge Q. Okay. Now after disconnecting the battery, now we are introducing slowly the dielectric medium here. Now what will be changes here? First one. What is it change to capacity? Let the capacity is here, now its capacity be C dash. Now capacitor depends on its intrinsic property, its dimension, its intrinsic property, whether it is filled with vacuum or air, or whether it is filled with any dielectric medium, that decides the capacity. So QV doesn't decide the capacity. For a given capacitor, capacity will be same. So let's in the same way, what is C dash? C dash will be same like K times epsilon naught A by D. So capacity will increase by K times. Second one, what will happen to its charge? Remember, the battery is connected to capacitor, and for given applied voltage and having its capacity C, whatever charges it is storing, let it be Q. After disconnecting battery, remember, even you introduce dielectric or whatever medium you introduce, so charge remains same, because you are neither removing charge nor you are taking, adding charge, because battery is disconnected, charge remains same. Therefore final charge will be equals to initial charge remains same. Now third case, here what will happen to voltage, potential difference here? Here battery was there, initial potential difference, let this be V. Now when battery is disconnected and dielectric medium is introduced, then what will happen? Arrangement of dipole molecules will be there. So some energy has been given to arrange them, and everything setup will happen inside the dielectric. So what will happen to dielectric? Let me go with this equation. C is equals to Q divided by V. So therefore, what is V is equals to Q by C. What is the Q here? Q remains the same. C value we know it is K times. This is a formula without dielectric. Let me say this is a formula, okay, with dielectric. Anyhow, Q dash remains same. Q dash is equals to Q. So C dash will be equals to K times C. So this is V dash is equals to Q by C is what? What is Q by C? It is V. Therefore V by K. Therefore potential will decrease by K times. Potential difference here will be decreased by K times. So after introducing dielectric, potential difference will decrease. Right? So therefore potential difference will decrease by K times. Right? Now, in the same way, what will happen to energy stored? Initial energy stored when battery is connected, it will be, can I go now this time Q square by 2C. Why this formula? This is, as you know, Q is same here in this case. So only variable is C. You can very easily understand the variation of energy stored in the capacitor with variation of C. You can even take half CV square also. There C is also variable and even V is also variable. Who will be overcoming who, which one and all, and that's complication. So better I will take this equation as Q is constant. So definitely U dash final energy after disconnecting battery and putting the dielectric, final energy is equals to Q square divided by 2 C dash. What is C dash? C dash is K times C. Then it will be 1 by k times q square by 2c is what u. Definitely energy stored will decrease here. Energy stored will decrease. Initial energy will be q square by 2c. Final energy is u by k, means energy will decrease by k times, right? So the energy will be used to arrange the dipole molecules, okay, in the direction of electric fields. So some energy has been lost. That energy, what lost energy is there, we are finding here. This is what energy after disconnecting battery and introducing the dielectric. This is there. Now what will happen to electric field? Electric field. So electric field, you can write it like that, V by D, as V is also, as D is not a variable, it's a constant. As what is V here? What is the final potential? It's a V by, what is the final, this is okay, let this be, this is okay. What is E dash? V dash by D. V dash will be what? V by K into D. Then what is V by D? It's the initial electric field. This is K. Therefore electric field will decrease by K times. Even we can verify in another way also. Lambda dash is equals to sigma, any of charge remains same, sigma by epsilon naught. What is sigma here? Sigma will be Q by A, but medium, if vacuum is there, I will retain epsilon naught. If some other medium is coming here, then the permittivity of that medium will be what? K times epsilon naught. Therefore 1 by K, I will write it separately. What is QA? It's again QA, it's the initial electric field. Okay, let this be initial electric, this is initial electric field. Okay, this is the initial electric field. Now I will take the final electric field, will be like that. This is final electric field. Therefore electric field is equals to 1 by K times initial electric field. Electric field is also decreasing. Electric field is decreasing, potential energy is decreasing, even potential difference is also decreasing, charge remains same, capacity anyhow will increase, it depends on its own property. So this is what increasing, this is what the decrease in electric field, right? So lastly, I conclude here, dielectric plays very important role in increasing the capacity, in increasing the energy storing capacity. As you can take here an example, in this first case, introduction of dielectric without disconnecting battery. Here potential difference between the battery is not changing, between the capacity is not changing. But remember, energy is increased here. Without increasing potential, we have increased the energy storing capacity. We have increased the even charge storing capacity, K times Q. So that's a good thing, that dielectric medium will help in many ways. It will help in making the making the plates to stick, making the plate to stick between each other, right? So dielectric will create an advantage of like, if suppose without dielectric, if I bring the plates very close, how best close we can place like that? It's very difficult to maintain the two plates close to each other, because C is equal to epsilon naught A by D. As D decreases, C will increase. How much D you will decrease? Like without dielectric, how close the plates you can bring? It's difficult to maintain closeness, right? Even A you have to increase the capacity, right? So if plates are between the plates like gum type, like dielectric medium is gum type. So plates like a simple layer of one single layer of small layer of dielectric, and then here if plates are being sticked here, like increasing capacity, like mechanical way also the dielectric medium is helping. So like layer of dielectric medium will become a gum type, and it will help us to make the plates stick each other, and it will help us to increase the capacity. And another way, without increasing voltage, that's very important. If you increase capacity with the increase in voltage, then there is a possibility of dielectric breakdown of the medium. Without increasing potential difference, it will increase charge storing capacity, it will increase its capacity value also, it will increase charge storing capacity also, and even energy storing also increases, provided potential difference will not appreciably increase. So that's where the breakdown will dielectric breakdown will not happen. That's also an advantage, yes, right? So thank you today.